Got your breath?
Oh, figure where it's starting.
I'll start off here with an introduction of the gentleman we have up here with us. Most of you remember Milton Wendler as our flight director, Dr. John Ziegelschmidt, the flight surgeon, and we have also Granville Pauls, who is the guidance officer. And I may have to get some help here. Granville Paules. Is that right? And we'll start off with a summary of the shift from Milton Wendler, and then we'll open it up to your questions.
Okay, is that all right? Sound okay? I started off around 30 hours in the middle of a communications test, which we did about half of at that time, and then we had to stop while we passed the TV down from the spacecraft. And I expect everybody knows more about the TV now than I do, since I didn't have a chance to get a good view of it. Wished I could have been watching the ball game and all that. As you're aware of, we did have a problem with the long-range lens, and really, before you ask me a bunch of questions, I guess the people are over now in Building 15, the IESD, Instrumentation and Electronic Systems Division, looking into why the long-range lens didn't work. And the words I get so far are essentially that the camera is working okay, but just that we were so close to the Earth was so large, it's about 3 degrees, the lens angle is about 9 degrees wide, and the Earth was covered with a fair amount of clouds today apparently, and the light, the contrast between what the space and the bright Earth was such that it actually overdrove the electronic, I guess you'd call it a lens control. There's no mechanical stop for that. And we're looking at some filters now and trying to duplicate this. Of course, tomorrow we'll be a little bit further away from the Earth, and perhaps that'll change the light settings enough that we'll be able to make that lens work. But apparently there's no real mechanical or electronic problems with the TV camera itself. And as you know, we put the other lens on, and the camera itself worked okay. So that's going on right now, and we're trying to sort all that out. But we certainly hope we're able to get the TV fixed by tomorrow. I'm just as anxious as everybody else is to see what that view looks like. I've been looking forward to it now for several months, so I'm going to be real disappointed if we can't make that work. We went ahead and finished the communications check. The crew asked us if we could kind of adjust the sleep cycles a little bit and change the flight plan around, and as you probably are already aware of, the flight plan between now and the actual LOI maneuver, or the last 5 or 6 hours prior to the LOI maneuver, is fairly free of activities. And we have told the crew that they're in the best position to decide which one of them needs the rest the most, and that essentially they should go ahead and have the one that needs the rest go ahead and sleep, or the ones, in some cases 2 of them are asleep at the same time, have been. And they just let us know what they desire, and we'll work the flight plan around them. The only real things that we have left to do now that we've finished the communications check is to do, at that time, the time I'm referring to, we had one more P-23 sighting to do in that immediate time frame. We put that off for a couple hours and did it about 36 hours elapsed. We have 3 more to do, and we can very easily work around those and move those back and forth. So there's no real problem in doing what the crew asked us to do here, and they're going on the sleep cycles that suit them. The idea being to be back on the timeline, the sleep line, if you'd like to look at it that way, by the time we get to LOI, and have the right amount of rest, built-in rest, or whatever you call it. So we are essentially in that mode of operation now. When I left anyway, the commander Borman had been resting. He did communicate with us a little bit to indicate that he wasn't completely asleep, or he at least wasn't asleep all the time. Bill Anders had been asleep for quite a while, probably had at least been off the loop ever since about 34 hours, and had planned to sleep until around 40 hours. And Lovell took a nap there starting about the same time, probably around about 34 hours. And he was the reason that we delayed this nav sighting, was to give him a couple extra hours of sleep, and he woke up, sounds very well, and did his nav sighting. In fact, we are pleasantly surprised, not surprised, but we are pleased at the fact that he's able to run through these nav sightings using less fuel and taking less time than we had seen him take earlier in the flight plan. The same thing, I guess, happened on Apollo 7. The crew became, of course, quite proficient at doing the platform alignments and nav sightings, the things that they had to do with the optical system. So he's going along fine, and essentially Borman is free to sleep or do whatever he chooses, really, for the next many hours, I guess, certainly past 43 hours and even longer if he chooses to do that. Some of the other things that have happened, the communication continues to be better than expected. If you copied some of the air-to-ground loops, you're probably aware of the fact that we went through a couple of periods there where our communications to the ground stations, the remote sites, went down, the landlines went down. The people at the ground station themselves were able to talk to the spacecraft and told them that it was a ground problem and to stand by, and in, I don't know, some 10 or 15 minutes in one case and a couple of minutes in another case, we were able to restore the landlines. The long time being due to some blown circuit breaker in a panel up at Goddard. So but in general, as far as the air-to-ground comm, it's going very well. The passive thermal control is going as it has been doing previously. We're able to do that quite adequately. The nav sightings, as you are aware, we have had a little bit of, I guess you'd say it's difficulty in identifying really some of the stars and making the sightings on those with a particular relationship we have to the sun and the moon being relatively in the same part of the sky. In fact, if you have some detailed questions about that, I'm hoping that Grant will be able to answer those in a little more detail. But it's as I believe I said last night, and perhaps as was mentioned earlier today, that even though we've have had some difficulties, we've been able to accomplish all of the star sightings and have done the navigation quite well. And when Lovell woke from his nap, while he proceeded to execute several, I guess you'd call it practice runs on the spacecraft computer, and these all checked out very well, and so we essentially are quite happy with the onboard navigation. And this also is in Grant's specialty area, so he's able to answer some questions along those lines. The trajectory information is tracking very nicely. Our mid-course 3 right now is showing up to be less than 1 foot per second. In about 3 hours, I guess we'll decide whether or not we should try to execute it. If it stays as low as this, I don't believe we will. And then the next time we have to make one is a mid-course 4, about 5 or 6 hours prior to LOI. And that one right now looks like it might be 4 feet a second if we should choose not to make mid-course 3. So the trajectory tracking is going along very nicely, and we're able to predict that. I guess you could say, as expected, we had been a little bit concerned with some of the water boiling and water dumps, and sure enough, we can see those appear in the trajectory, and we're able to actually verify that that pounds of water being dumped overboard sure enough affects the trajectory like we thought it would. And that is a tracking, I should say, and the trajectory, and we're able to take our data over a long period of time and get that all sorted out. And I believe that's the major parts of what happened. I don't know if you can think of anything I might add to it right now before we ask for questions. Oh, let me tell you where we are. We're squealing, I guess. That's one place we are. Am I too far away or too close? or both. At 39 hours, we were doing around 4,000 feet per second, and we were at 141,400 nautical miles from the Earth. And we're still slowing down, although not quite as much, and I'm not sure just when we'll get into the moon sphere, but it should be in a few more hours. In fact, Barry Grand knows that number. But 55 hours, he's saying, we'll start speeding up again. So that's where we are.
Okay, we'll pick up with your questions. Catch this one back here first.
I understand LOI 1 has been moved to 69 hours, 10 minutes, about 3 minutes later than originally planned. Is that true? And will that affect LOI 2, TEI, and burn times and reentry and all that?
I'm sorry, I don't believe I heard all of your question. You started off by asking me if you said you understood LOI 1 has been moved up or behind 3 minutes.
First of all, yes. Is that true? Is that correct?
Well, moved up is probably the wrong way to say it. We have some nominal time in the operational trajectory that's calculated based on a lot of things being exactly zero, like all the mid-courses, etc. And you know we made one of 24 feet a second, and it's like a lot of other things in the flight plan. Nobody had really expected LOI to be at exactly the time that was predicted a month ago. Mm-hmm. So it's now 3 minutes off of what we predicted a long time ago. So that's
right.
It
so
may change a little bit more, but
Wait for the mic here so we can get this on the...
So it is about 69:10 as of now.
I believe that's right, yeah.
And will that move back 3 minutes, LOI 2 and TEI, as of now?
I guess I really don't know the answer to that. I'm sorry. Probably would stay in the same relation. I don't worry too much about 3 minutes and those maneuvers now so many hours ahead of time. Well, if you could tell me some more about why you're concerned, perhaps I could answer it that way.
Well, our TV coverage has involved real-time animation, and we would like to hit it when the astronauts.
That's one concern.
I see. You're worried about syncing, but of course, we will know that in the last, really quite accurately in the last probably 10 hours, I would say, which would, yeah, is that certainly right after we execute the last mid-course is really, the residuals from that have some slight effect if you're talking in terms of a few seconds here or there.
Right here.
Dr. Ziegelschmidt, do you think we could have a medical report?
What's your question again, please?
For Dr. Ziegelschmidt, if we could have a medical report, please.
Didn't you like my medical report?
Okay, the significant item here tonight is the reporting by Frank Borman at 33 and a half hours ground elapsed time. That is, temperature was 97.5 degrees Fahrenheit. And this is no change since the last time he measured it earlier this morning. In other words, at no time when we've measured temperature have we found it to be elevated. And I think this is good news, and another personal observation is the fact that during the last few communications which I heard, listened in on prior to coming over here, Colonel Borman seemed in extremely good spirits, and the quality of his voice was more that which I'm used to. So I think he is recovering successfully from his minor indisposition. Okay, the other two gentlemen are currently asleep. We are seeing for the first time the LMP, or Jim Lovell's, heart rate while asleep. Now he's probably therefore in his couch rather than in the sleep station. I didn't get confirmation of that. Okay. I just was advising Flight that this was a fact. He was kind of doubting me.
Bill Anders is in.
But the point I was going to make was he had earlier been awake.
That is
And
correct,
it-
right.
we're talking about numbers.
But we noticed a decrease in his heart rate and suspected that he was asleep. And Colonel Borman, just prior to coming over here, informed the ground that Jim was asleep at this time. And of course, Bill Anders has been asleep for several hours now, and we haven't heard any more from him. The latest prior to his going to sleep was that we have had no report of any more symptoms, so we can assume from their lack of description of further symptoms that they're doing well.
What are the principal reasons for the spacecraft loss of weight? Is it the RCS fuel or the water dumps, or how many factors are affecting the loss of weight? Or is there one principal one?
Well, I really didn't look up those numbers, but we did. Since when do you mean the loss of weight? Since when, perhaps?
Since the spacecraft started in space,
Well, I'd have to say the answer to that then would be the SPS burn, if you're going to go back that far, since we did make a 2-second burn with the large engine.
I'm sorry I went back that far.
Okay, pick another time.
Yeah, let's take it from lunar orbit injection. That after the separation from the third stage.
Okay, we of course made the SPS burn after that time too.
Right.
That's the biggest, and I don't have the actual weights. May have to call upon our return to Earth officer back there in the back row if you want to get down to weights. But we have used RCS and we have dumped water.
So those would be the two principal things.
Yeah, those are really after, except for that mid-course maneuver back at 11 hours. Why, those are the things that have caused us to lose weight between then and now.
Let's go over here and pick up on.
What kind of, Dr. Ziegler-Schmidt, if Lovell and Anders are to develop this intestinal upset, what kind of time would you expect to see from when Borman had it to when they might come down with it?
Well, since they all are coming down at the same time, I don't see that there would be much time lapse between the onset of symptoms and the other two crewmen. Now, they both have had nausea previously. They may only experience this symptom. In other words, there may be no further symptoms. With this type of situation, some people react differently. Some people will get nausea, others will have vomiting, others will have vomiting and diarrhea or diarrhea alone. So this is hard to say, but I don't anticipate any more symptoms from either the command module pilot or the lunar module pilot.
Under the assumption that the nausea they experienced earlier was explained by this so-called motion sickness from free floating around, and also under the assumption that perhaps they had not been exposed to this bug prior to Borman's coming down with it, how long would it take? What would be the incubation period for them?
Okay, if we assume that this, and I think we must go on this assumption based on current evidence that this is a viral type gastroenteritis, the incubation period is approximately 72 hours. And of course, this means that they could have gotten exposed to this just prior to launch and not come down with it or have the symptoms recognized in any shape or form pre-launch, you see. And we, of course, do special studies on F-0 physical to culture the throat washings for viruses, but you must appreciate the fact that it takes about 2 to 3 weeks to get the results, and then these results if you are going to isolate a virus, it's very critical to get this culture just at the onset of symptoms. So we may not get them. We did not get isolate any viruses in the prior period.
We just completed the canister change.
Dr. Ziegler-Schmidt,
Apollo 8
how often
Houston,
are you
roger,
monitoring
copy.
temperature, and are you using the same instrument that was used on Apollo 7? And have you noticed any elevation of temperature above normal in any of the crewmen since launch?
Okay, let's try the reverse order. No, we have not. We've only made 2 measurements, and they've both been on the commander, and they've both been normal. They've both been approximately 97.5, which is certainly normal for an oral temperature. It is the same thermometer, if you will, that was on Apollo 7, and the crew were briefed properly in its use, and I think there's no doubt that this is a valid reading. The frequency of temperature will depend, of course, on the symptoms. We don't like to interfere with the crew if they're busy. Of course, if medical situation dictates, we'll take it as often as perhaps twice a day. But currently, I've only taken it twice today, and once a day is probably an ideal situation unless the symptoms get worse.
Dick Lyons here, and then we'll go back to back.
All right, 2 questions, please. Dr. Ziegelschmidt, there was a permission to take Marazine given before you came on the shift. Have they taken any Marazine, and have they taken any other medication, another Lomotil tablet apiece, anything?
Okay. The previous flight surgeon did authorize the Marazine. However, we have no confirmation as to whether they did or did not take it. I suspect they did not take it because the symptoms did subside, and I would be my guess.
Lomotil again. Lomotil again.
I requested that Colonel Borman take another Lomotil tonight at approximately 36 hours ground elapsed time. Not because he was experiencing symptoms, but I would like to see him have a good effect prophylactically. So I did order another one, but he did not.
He did take it.
Yes, sir, he did take it.
Okay. Now, Doug, I'd like to ask a question, please. How many ground to or air to ground communications in the so-called private conversation mode have gone on during your shift, and how many have not been relayed through the mission control loop here? And what was the content of those that were not played?
We had none on my shift, and I don't recall exactly how many Paul Haney had on his. It was 1 or 2.
1, I think.
But on this shift, we have had none. Let's go back here to the back and pick up a couple back here, and then come back up in front. Ed, I'll get you next, Ed.
What will you do if one of the astronauts becomes seriously ill?
First of all, you can treat the symptoms or make a diagnosis and treat accordingly what's available in the onboard medical kit. If this is insufficient, then we have to face the possibility of altering the flight plan. We have not obviously had to do that in past experience and don't anticipate to do it in future, but it's always a contingency which must be considered and can occur. Just like any of you could get sick today and not make this press briefing. It's just that simple.
I might.
That certainly depends on whether we abort the mission or not. Depends on many factors. Certainly the severity of the illness, and it's a management decision which many people will be in the loop on.
Let me point out something I should have said earlier, I guess. Our trade-off now is our basic abort method, you might say, the one that requires about 5,000 or 6,000 feet a second, actually lands us around 99 hours in the Pacific. So the trade-off now, in the case that we should, trade off the times and the big burns and so forth against the crew condition or any other situation, we are trading off roughly 100 hours or 46 hours, 48 hours. So that's a trade-off, and you recognize as we get closer to the moon, we get into a position where it's quicker to, or just as good to come on around the moon and come back that way. And we still have an option of making a burn on the far side of the moon that would get us back into the Atlantic at around 137 hours. So the trade-off now to come home is getting very smaller and smaller, but it's not as straightforward as just, turning around and coming back.
Dr. Ziegelschmidt, some points for clarification. The previous flight surgeon indicated that he would be extremely surprised if Lovell and Anders do not come down with this same thing that Borman has. I gather that you at least would not be surprised if they did not any more than the nausea they've already experienced.
Well, let me interrupt you a minute. I think they are indeed suffering from the same affliction. They're just the manifestations are different in the crewmen, which you'd expect in any biological systems.
Okay, number two, the two indications of temperature that you've got on the CMP were both normal. Earlier we were told that Borman had chills and fever.
On the commander.
I'm sorry,
CDR.
correction, yeah, CDR.
Gotta
Earlier
keep
we
you
were
honest.
told he had chills and fever.
Right.
These two would not be an indication that he did not. Is that correct?
No, what I'm saying is the two times it was measured, it was normal. He did experience some chilliness on the first, or about 19 hours into the mission, at which time he did not take his temperature, and we weren't aware that he was having this, so we cannot say that he did not initially have a febrile period, but it was a very short duration, and the fact that he's remained febrile today is a very good sign.
Okay, and one for Milt. During the TV pass, Milt, we noticed a certain amount of wastewater outside the window, and also Borman made the comment that they were shooting through a hazy window, a dirty window. One, I recall during 7 that Wally timed his dumps for that period when he slowed down so he didn't accumulate wastewater around the spacecraft, or any maneuvers being made during this flight to avoid them flying around the moon in a little cloud of water and having interference to the photography that way. Number 2, is it predicted at this point that the fogging of the windows will interfere with the photography at the moon in any way?
Well, gosh, you asked a lot of questions there. First of all, our water dumps or non-dumps have two priorities. Number one, going out, we're timing them so that they occur where they have the least effect on our trajectory runs, which are associated with these mid-course computations. And we are looking now at our present rate of heat transfer through the radiators to verify that what we thought was what we would need from the augmentation from the evaporators, which are another source of water, as you recognize, are correct in lunar orbit, there being a higher heat load there. So we're looking at that to see if our schedule is correct, and we will plan to arrive at the moon with the amount of water that we need to carry us through this high heat load period at a certain boiling rate. So we're, in that sense, we try to boil as little as possible, not necessarily, well, for both reasons, for photography and also from the point of view that it interferes with our landmark sightings with the little specks flying around all around the optics. And they have commented on this, that they look like stars. They can't tell them from real stars, and also on the effect that it has on the trajectory in lunar orbit. So, and the windows, I guess we just don't really know what effect that's going to have. The one window remains fairly dark or opaque. The other 4 windows seem to still be useful, and we assume that that'll be satisfactory when we get to the moon.
Go right
Yeah,
here.
2 are completely clear as far as we know now, and 2 are slightly hazy, I guess is the word.
I'd like to ask Gran
I'm
about
glad you're doing that. I was afraid he wasn't going to get a question.
about 3730. There was a conversation in which you passed up some uncertainties: 12 miles in position, 1/4 of a foot per second in velocity, and 5 miles in perigee. And then shortly afterward, Jim ran 3 different sets of data through the onboard computer and came up with 3 different paracynthions. Can you discuss this? Is the trajectory information with these uncertainties, is this considered good or bad? And is there any significance in the fact that the ground paracynthion was plus 64.2 and using other data it was 84.7 or something, Jim said, "Thank goodness they're all plus," or words to that effect. You remember that?
Yes, I
event?
remember that. Right. The numbers that he got on board were based on a vector which he has been building through an internal computer scheme, and it's one of the things we were really interested in getting for this mission. What he does is he's sighting on two celestial objects, or one being a star and the other being the Earth or the Moon, depending on whichever target he picks, and by a triangulation scheme can do an onboard estimate of his ephemeris. And that's one of the reasons why we're so interested in how well the optics perform. It requires optics measurements, some initial information in the computer, and then continuous marking and updating, weighting this information together and coming up with an internal onboard answer to where his orbit really says he is. Then he would and what we did was we keep an eye on this, and throughout the mission we've been keeping this data that he has generated together on the ground, and the marks made at 37 hours there were the last set of these sets of data that he had done, compared with an onboard vector we had sent him set over in another slot. Now this, he has two places he can keep track of this information on the trajectory, and the numbers he read out, for instance, I believe one of them was 84.7, and that was based on his vector that he had determined on board as a paracynthian altitude. He went through another routine, a different method of determining this paracynthian altitude, and got the 82.6 number. These were using the same vector, but computing the answer two different ways. The number which we quoted to him, the 64 number, all right, now he has this other vector which we sent him earlier, and he doesn't touch that one. He doesn't let any of his navigation affect that vector. It always is there for him to pick up and use if he needs to do something. And for instance, in an abort case with loss of comm, there is a good vector. He can always go and recover. It's the best world vector, a misfin vector we have given him in the past, and that was sent up at something like 28 hours. He took that vector and ran it and came up with the plus 64. That still fit the one we had on the ground, which was indicative of the fact that the mid-course is so small. The upcoming mid-course is so small. The 84 number and 82 number, to get back to the whole point you're interested in, we're very happy with these numbers. The math physics people have been keeping a real close eye on the data, and it looks like the command module pilot, Jim Lovell, is doing a real good job of marking. It requires a very accurate marking on the optics, with the optics, in order to make these things come in. The weighting of all these marks fit into this vector real well. And this seems to be working out extremely well. Everyone's real happy with it, and I think to see exactly how well it has worked, it'll probably take some more analysis of post-flight data.
Is the data that he's generating on board good enough to bring him back into the reentry corridor if he should have a total loss of comm?
I hate to say right now, looking at the data, it's getting better, and the objective of the onboard routines is to continue this type of taking marks and weighting the data. I would rather think that we'd want to look at the numbers as he got in closer and had a chance to weight all this marking all the way up to the moon, say, for instance. And then he did it. Actually, the program is designed to do this, and this is what the analysis that the people on the ground are really looking for. I think I wouldn't want to say at this point how well it would do. We're hoping it would get him back alive, and that's the whole objective.
You understand that's a perfectionist speaking. Am I on? Okay, you understand it's a perfectionist speaking there. I think the thing to say here is that we have felt like if the computer performed up to spec, that it would do the job and get him back early. And what Grant is saying here is that it is doing better than the spec value here, and the people are performing, and it's, as far as we know now, that we think it's going to be satisfactory for the entry. And let me point out one other thing real quickly. We took I think I mentioned last night that we had one set of fairly critical horizon sightings to measure the kind of delta horizon to update the computer, and we actually computed that in one of Graham's cohorts actually updated the computer program based on our real-time information, so we are squared away now for the entry phase and have that constant in the computer updated.
I think I was answering the question a little too specifically. He will keep marking these things. The weighting will get better, and the answers will get better. I was more or less answering it to the condition he had at that instant. It seems to be going that way.
Let's get this one back here, and then we'll come up front.
Doctor, to get back to these pills, Borman at least took Seconal once. They're still having trouble with sleep, apparently. Is the Seconal out? Or why aren't they taking it?
Is it Seconal out, you say?
Yes. In other words, Borman took it once.
Right.
Since then, they've been having trouble sleeping. He had trouble sleeping in the second cycle. Lovell and Anders are not sleeping out. Are they taking the Seconal, or is the Seconal out completely at the moment? And if so, why?
No,
This basic question, I think it's got a misunderstanding. You're saying that they're having trouble sleeping and they're not sleeping now. Did I understand you correctly, sir?
I understand from the tapes and from Dr. Berry that Borman slept 5 hours the first time, 2 hours the second, and from the tapes that Lovell and Anders weren't sleeping out, and that you all gave them permission to juggle the schedule so they could get the rest.
That was several hours ago, of course, and actually Anders has been asleep for quite a few hours now, and as far as we know is sleeping.
I think
let me put it another way. The Seconal pill that Borman took is the only one that has been administered.
No, there was one taken this evening by Bill Anders.
All right, now,
prior to initiation of his sleep period, and he is asleep and has been sleeping. I believe the time is approximately about 34 and a half hours GET.
All right. Now, two, on the Lomatil,
Roger.
They all took it once. Then Borman, the word came up from the friendly flight surgeon, as the tape put it, was to take another one. Well,
yes.
Now, is that his second, third, fourth, or what?
I see. Sure. That is his second.
Now, will he be getting, do you plan to prescribe for him at regular intervals at the moment?
If he has no more symptoms, I think we'll just dispense with it after that. Usually it takes only 1 or 2 dosages in mild cases to abort the symptoms.
All right. Now, one other question for these technical people. Is the 44-hour period, 44-hour get, still the commit point for a lunar flyby? In other words, we were told that if you get out to 44 hours, then it's quicker to come back by going around the moon and coming back direct to Earth. Is the 44-hour period, I'm not saying whether it's 44-1 or 44.
Yeah, that's essentially is correct.
But once you're past 44 hours then, they go around the moon at least.
You're talking about if we have to terminate the mission, or we desire to. Yes, the hours may not be exactly right. That was what I was talking about earlier. Now, we essentially are fairly well satisfied, and they have a pad on board that if they lose comm, they have the option of continuing around the moon, assuming the systems are okay and that.
Okay, we got time for 2 more. Take these up there.
I'd like to follow up Ed DeLong's question earlier. Are the windows currently a factor in your decision to go LOI, or if all of them are as bad as the hatch window, is there conceivable that you would not go LOI because the windows were too fogged up?
Well, you're assuming yes, and the answer's got to be yes.
I don't mean black. I mean,
yes, I'm assuming that there could be a worst-case window situation where we would decide that you might call it the risk in doing the LOI was not worth the gain because they can't do any of the lunar sightings, or at least they would be very difficult. They could still do them with a telescope, but probably we would. Right now, mostly we're thinking about how we would do things a little differently if one or more of the windows is is not, you can't look through it very well. By differently, I mean we might use a different attitude. We're not now considering no-go in LOI for this reason, although it's one of the factors. Give him another chance.
And is the reason, is the critical factor photography, or is it landmark sighting for
that
navigation?
probably depends on who you talk to. As far as I'm concerned, is that it's the landmark tracking is the big thing here. The photography is very important to us, but it's built around the landmark tracking, really.
One more right here.
Doctor, on the basis of all the medical evidence you have now, will the astronauts be in a condition to go for LOI, or won't they, as far as your prognosis is concerned?
We all have a little bit of doctor in us. I would say based on... Say again?
I say I'll give you my doctor's opinion.
Yeah, that's what I mean.
We're going to be go.
Based on what we've seen today, I'm certainly quite optimistic that we're go for LOI at this time, and don't anticipate anything which would interfere with that goal.
As far as LOI is concerned, with that 3-minute change, I gather this doesn't change the position that the spacecraft will have in the backside of the moon. And if that's so, what is the communications problem? How many minutes after LOI, if you don't have communication, will it take before you know that there's been LOI?
I believe it's about 15. Is that, you checked on that probably since I did it, something like that though, 15 or 20. I believe that's what it is.
And is that the same for LOI-2 and TEI?
It's about the same for each
15
one.
to
It
20
varies a little bit based on just where you execute the maneuver, but
that's an approximate.
yes.
Thank you.
It's going to be a long, whatever it is, 10 minutes, it's going to be quite a long time.
I'd like to thank you for being here. I think we're going to have to cut this off now and let these gentlemen get some sleep. Okay,
We'll stay a while longer. We don't want to send anybody away.
Unhappy?
Too unhappy.
All right, this is
I
a
wasn't
question.
being facetious, I'm certainly.
This is a question about the weight of the spacecraft. Your flight plan specifies that at this point in the mission, the spacecraft should have a certain weight. It, according to the latest information, it's 765 pounds below that weight. Why is this?
Okay, my semi-educated guess, fairly educated I'd say, is because we made the 2.4 second SPS burn, which you aware puts a lot of propellant out, and that was not in the flight plan. All those burns are zero nominally.
Excuse me.
But you understand, of course, that the weight is not a very big factor. We want to know what it is, which we do know.
Well, excuse me, but you make an allowance in your flight plan for a 120-foot delta V change up to LOI, and I presume the weight figure is based on that, and you only expended about...
No, excuse me, go ahead with your question.
Well, there are allowances for much larger amounts of SPS burn.
That is true, but the flight plan, if you look at there, you'll see all the mid-courses say nominally zero, and since that's our best information, when they work out the consumables, that's the consumable, the weight number that they put in there. But we do reserve the 120 that you mentioned, plus some others like that. But we don't take them into account with the weight because, our best information says that we won't use them.
All right, admitting that, there's apparently 6 pounds of propellant give you, what is the ratio between a 1 foot per second delta V and your propellant mass?
Goodness, I should have brought my curve with me. This, Gran, you help me here. This changes, of course, based on the weight.
This is early on in the mission.
Yeah, we're heavy now, and we don't get as
spaceship.
much per pound of propellant as we do later on. And you're talking about SPS, is that correct?
Well, yes, that's what you're talking about.
Oh,
What
there's
changed
a big
in the weight?
nomograph that tells you all that, and I didn't bring that with me. I'm sorry, but I might can get you the answer before we leave tonight if you'd like. That would be adequate.
Okay.
We have a weight expert here that worries a great deal about
press him
that.
into service. 6 for 1, he's saying. 6 what for what? And that the SPS at the heavy weight now is 6 pounds for 1 foot per second. Okay?
Borman was asked just before you fellows came over, have you seen the moon lately, Frank? He said, no, I saw it yesterday.
How about that?
I'm curious here. Here these three guys are out on man's first trip to the moon, and he doesn't even look at it.
Okay.
Wait a minute. This is the whole world wants to know his impressions of this trip. Is it because he doesn't give a damn? Is it because he's too busy? Is it because the spacecraft's pointed back at Earth? What's going on here? And there seems to be very little discussion. I know he's a phlegmatic kind of guy and all that business, but the people would like to know what his impressions are as he goes out on this great trip.
Okay, perhaps you missed a point in his commentary while you were coming over here, because we heard it after we went off shift, and you might have already been over here, but he expressed his concern about the TV and how he wanted to share the view that he had with the people back here, and he is definitely concerned with trying to describe things. Now, I think we was joking when he said he saw it yesterday. Of course, I'm pretty sure I haven't asked him when the last time he saw the moon was, of course. But the thing you have to recognize is that we are set up in this passive thermal control attitude, which is actually kind of points him out in the middle of nowhere, you might say, as far as his viewing is concerned. And he's not free to drive the spacecraft around and hold it in an attitude to look at the moon or the Earth. And this is he accepts what he can get.
What does he see during this role? He must see the Earth and the moon. What's the point?
No, not necessarily. In fact, I don't believe he sees the. Well, we did give him a 20-degree change in the attitude so he could see the Earth a little more often. But do you know, Grant, how often he can see the Earth?
No, I really don't know how often it is, but with the PTC attitude, it isn't optimum for doing that at all. He just, like you say, may get glimpses often.
We're in about 1 rev per hour condition, so it would only be, for a few minutes every hour, presumably. It'd be the normal way you'd see it. And approximately 1 rev per hour. We have been 1 rev every 45 minutes. 48, the doctor is telling me here, it was one time.
What about when they do a platform alignment to take a star sighting? Doesn't he have to line up with a horizon then, the Earth's horizon?
No, he lines up with the stars.
He lines up strictly with stars?
Yes.
Milt.
You understand, he's using this little 1-degree sextant to do that, and he actually bore sights on one little star. The Earth wouldn't do him any good at this point. Now, it may when he gets further away, but it would fill the sextant completely at this point.
Milt, it was my understanding from some of the trajectory people.
I can't hear you.
It was my understanding from some of the trajectory people that the crew had requested, and that it had been done, that they would see the Earth or the moon fairly frequently going out and back so they could retain some orientation just within their own minds. And this what you're saying now would seem to negate that.
Well, I didn't mean to imply that he's not seen it for many, for long periods of time. And I did say that they had changed the attitude a little bit so that it would give him a better chance for the reference that you're talking about. But the fact remains is that he's kind of pointed off in the middle of space. And they did comment on what the Earth looked like. It was getting smaller, if you heard that over the loop. So they are seeing it, yes. But he asked me the question, why aren't they looking at it? Was okay. All right. But they are certainly impressed with what they're seeing and are describing it as best they can, I think.
Graham looked like he was scribbling
were you trying to speak, Graham?
down there.
No.
Were you figuring out, by any chance, how often do they see it? Do you have any feel for this?
If they're looking for it?
Yeah, if they're looking out the window.
Well, I'd hate to say, really, that it depends certainly on their attitude, and this thing isn't an exactly fixed inertial thing. It rotates and it has wobble in it and so on. If they wanted to see the Earth or the Moon, they could probably find some way with the optics to do it, if they want to make an effort to do it. But
eyeballing out of one.
I really don't know exactly.
Well, we can find that information out by looking at the attitudes. No. Yeah. Say again? I didn't understand your comment.
Instead of all this comment about football
Okay.
Okay, gentlemen, we're going to have to stop this now. Let these people get some sleep, and ask to save some of these questions for tomorrow.
This is Apollo Control Houston at 41 hours, 31 minutes, now into the flight Apollo 8. The Apollo 8 spacecraft at this time is at an altitude of 147,151.4 nautical miles. It is currently traveling at a rate of speed or velocity of 3,912.4 feet per second. It's been a period of relative quiet here in the Mission Control Center. Our flight director, now monitoring the command module pilot, Jim Lovell, reports he appears to be sleeping restfully. Meanwhile, we're looking at the present time at a clock identified as the digital clock, identified as the LOS clock, which is counting down to that time when we'll have a loss of signal as the spacecraft Apollo 8 travels behind the moon just prior to its lunar orbit insertion burn. Our clock reading at this time mark is 27 hours, 24 minutes, 39 seconds away. Just a little more than a day away at this time. Since our last report, we've had only one brief conversation with spacecraft commander Frank Borman. It involved a canister change, and we'll play that conversation now. Apollo Control Houston, that, as you could see, was marked by its brevity. So at 41 hours, 33 minutes, 10 seconds into the flight, Apollo 8, this is Apollo Control.
Apollo 8, Houston.
Go ahead.
Apollo 8, this is Houston. We have a handover coming up in 2.5 minutes to Guam. Over.
Okay, Jerry, thank you. Hey, Jerry.
Go ahead.
How about any long-range guesses what the weather's going to be like in the recovery area on Friday?
Rod, Frank. Apollo 8, Houston, with a weather watch. Roger, Frank. For 7 degrees, 38 minutes north, 165 west landing area. We're showing 2,000 scattered, 12,000 broken, high over and 10, with the winds from the east at 12, 4 foot 12, about an 82 degree temperature. There'll be some rain showers in about 10 to 30% of the area, with ceilings around 2,000. If turns out to be a thunderstorm in the area, it'll probably have a ceiling around 500 feet. Apollo 8, Houston, do you copy that weather okay?
Roger, I said thank you. Do you read me now?
Roger, reading you much better. We got the voice coming down through honeysuckle now.
Okay.
This is Apollo Control Houston, 41 hours, 52 minutes, 35 seconds now into the flight Apollo 8. Our current altitude on Apollo 8 now 147,956.7 nautical miles. Our current velocity on Apollo 8, 3,892 feet per second. We've had a bit of a conversation with spacecraft commander Frank Borman, and we'll pass that along now. Apollo Control, Houston. As you heard, spacecraft commander Frank Borman did request a weather advisory for his time of return to Earth, and you certainly can't fault the spacecraft commander for not planning his mission in advance. At the present time, our communications, we're uplinking from Guam and downlinking voice data through Honeysuckle at 41 hours, 55 minutes, 46 seconds into the flight Apollo 8. This is Apollo Control, Houston.
Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Roger, Frank. Can you cycle the H2 and O2 cryo fans now for us?
Roger. We'll start her now with H2. Manual, 2 minutes.
Roger.
You may need to call us now and then where everybody's a little drowsy.
Okay, Frank.
That completes it, Jerry. They're all cycled through.
Roger, Frank.
Houston, Apollo 8.
Apollo 8, Houston. Roger.
Did you get my message about the fan?
Sure did, Frank. Thanks.
Okay.
This is Apollo Control, Houston, 42 hours, 21 minutes, 32 seconds into the flight Apollo 8. At the present time, Apollo 8 now 149,041.4 nautical miles in altitude. Meanwhile, our spacecraft velocity continuing to slow down. Our current velocity reading 3,864.7 feet per second. Since our last announcement, we've had only one conversation with Apollo 8, and we'll pass that along now. And that concludes the conversation, a procedural one. And at 42 hours, 23 minutes, 15 seconds into the flight, this is Apollo Control, Houston.